Hello all, my name is Swapan Mollik. I am working at SIMS NOAA NSSL. Today I am going to show some result on impact study using GOES or nighttime cloud water path assimilation into the Vernon forecast system. Before start my talks, I would like to thank my colleagues for their support and the AMS members for giving me the opportunity to talk on my research work. So, in brief, this study investigates the assimilation impact of nighttime cloud water path retrieval from GOES or geostationary satellites on high impact weather events using NSSL Vernon forecast system. One of the challenge in nighttime without visible data on the retrieval is their bias and error characteristic are significantly different from daytime retrieval. So it is important to understand and the study on the impact of nighttime cloud water path data in the Vernon forecast system. The result shows that the assimilation impact of GOES or nighttime cloud water path on the high impact weather forecast are positive and large for severe weather prediction. This is the NSSL experimental Vernon forecast configuration for Ensemble. So we are using WRF version 3.9. The horizontal resolution is 3 km with 51 vertical levels. We use 36 ensemble members with physics diversity, and initial boundary conditions used member of an experimental high resolution rapid refresh generated by Global Forecast Division run. We also use the data assimilation procedure, which is based on GSI ENKF system. GSI is used for observation processing components for observation innovation calculation, and whereas ENKF analysis components. To see the impact of nighttime cloud water path assimilation, we consider total 4 events in the year 2019. The table shows that the number of tornadoes, hails, and winds for these 4 convective events. For nighttime cloud water path retrieval, GOES are channels 7, 14, and 15 having wavelengths 3.9, 11.2, and 12.3 micrometer are used. Whereas in daytime cloud water path retrieval, GOES are channel 2 and 7. 2 is the visible channels having 0.64 micrometer are used. The figure shows that the total number of cloud water path observation accumulated on 22nd May 2019. The x-axis represent the time from 17 UTC to next day 03 UTC, and y-axis represent the total number of observations. So we can see that during night time, which is almost 1 UTC, near about the blue line is higher as compared to the green line. The blue line is the nighttime observation, whereas the green line is only daytime. So in daytime there is no observation after 1 UTC, whereas the night time the number is higher. These slides represents the domain of 4 convective events considered in this study, along with the observation assimilated cloud water path observation assimilated for a particular time 03 UTC for the 4 convective events considered in this study. Now coming to the results, this is shows the 1 hour for reflectivity forecast based on 02 UTC on 22nd May 2019. Forecast composite reflectivity greater than 45 dVg from using nighttime cloud water path data simulation and control run initiated at 02 UTC. The control run is without nighttime cloud water path data. The darker gray indicate more members generated convection at a particular location. Now coming to the performance in terms of reflectivity and 2 to 5 kilometer updraft helicity, we can see that the left panel represents the performance diagram on reflectivity in 60 minutes forecast. So using nighttime cloud water path is showing higher performance compared to control run, and the in 2 to 5 kilometer updraft helicity also clearly shows that the accumulating nighttime cloud water path, the performance is better than the control run. Now this table shows that the summary of total number of reflectivity and rotation objects accumulated over all ensemble members and 180 minutes forecast times for both with nighttime cloud water path and without nighttime cloud water path, which is control experiment, and for all the four cases considered in this study. So we can see that the total number of objects in terms of reflectivity and rotation is higher when we use the nighttime cloud water path observations. So the performance of nighttime cloud water path simulation in the 1 hour forecast is accessed using object-based verification method. The result of the impact of nighttime cloud water path simulation is showing positive and large for severe weather prediction. Multiple studies along with new convective events are required to see the seasonal impact. Future research will analyze the potential cloud water path data thinning strategies, including adaptive object observation thinning techniques to reduce the bias present in the model configurations. Okay, these are few references we use in this study. So these are based on the daytime and nighttime cloud water path retrieval methods with details and model configuration, 1 on forecast model configuration, and other details. And this is my last slide. Thank you very much, and I am ready to take any question. Thanks.